All right, so you hopefully have graphed y equals sine x, working through how we're actually getting where those points would be on the curve itself. And when in doubt, you can put y equals sine x into Desmos and see what that curve ends up being. The only thing is you need to make sure that you're in degree mode for this for now. It's not until you get into grade 12 that we change the measure of our angles from degrees into radians, but not to worry about that for now. So our sine function is a special type of periodic function that's created by transforming that graph of y equals sine x. So back when we did parabolas, y equals x squared was our most basic parabola, and every other parabola that we wanted to make was just a transformation of that one. So the y equals x squared was our base parabola, or our parent parabola. For this, y equals sine x is our base sinusoidal curve, or our parent sinusoidal function. When we graph our sine functions, we're going to use 5 anchor points to graph one cycle. Now, these sinusoidal functions always have this nice, smooth, wavy shape to it. Okay, so if you don't have that, if you've got some other things happening, for example, I know we had some graphs earlier on that maybe look like this, and then it repeated that. So it is smooth, it is wavy, but because you've got these extra little lumps and bumps, it's not the straight up and down oscillating between the two things. This one is, it's periodic, but it's not sinusoidal. So I'm just going to write that in. This one is periodic, but not sinusoidal. It has to have those smooth little waves to it. All right, now the 5 anchor points we're going to look at, sinusoidal, I can't write and talk at the same time apparently. There we go. The 5 points we're going to look at are what we look at in terms of graphing one cycle. So let's say one cycle starts kind of here in the middle, goes up, down, and back to the middle. That is like from 0 to 360 when we graph y equals sine theta in degrees from 0 to 360, because that would be one full revolution, 360 degrees. The 3 anchor points that we look at to start graphing are the 3 that appear on the axis of the curve. So that's what we're going to type in here. The 3 anchor points, or 3 of the anchor points out of the 5, belong on the axis of the curve. There we go, axis of the curve. One is at the start of the cycle, another is at the middle of the cycle, and the third one is at the end of the cycle. I think I'll put start, end, and then middle of the cycle. So when I graph my sine curve, I always start on the axis of the curve. I look at what my period is. I put a point on the axis of the curve at the end of the period, and then halfway in between those two spots will be the middle of the cycle, and I'll be back on my axis of the curve. The 4th anchor point that I draw from there, so I've got this point, and this point. The 4th one I draw is the maximum, and it occurs halfway between the 1st and the middle anchor point that was on the axis of the curve. And then the 5th anchor point will be the minimum point, which happens between the middle and the last one anchor on the axis of the curve. So now I'll have all 5 anchor points drawn for one cycle of my function, and then I join them together in a nice smooth curve. So our job now is to sketch a sinusoidal function that has an amplitude of 3, a period of 8, and the equation of the axis is y equals 1, and it passes through the point 0, 1, for 0 is less than or equal to x is less than or equal to 16. So it's only telling us really in terms of the period to go for a total of 2 cycles here, because one period is 8, 2 periods together would be up to 16. So let's put this into play here. All right, so my first thing I'm going to do when I graph will be to figure out where my axis of the curve is, because that's where I'm going to put my first 3 anchor points. And the axis of the curve is the horizontal line y equals 1. So I'm just going to dot that in across here just to visually give me an idea of where that is. Okay, so that's the curve the line y equals 1. It's going to pass through the point 0, 1. So 0, 1 will be the point right here. So that'll be my first anchor point. Now, The next thing I'm going to do is look at what the period is. The period is 8. So if my sinusoidal curve is starting at 0, 1, it's going to have to finish up one full cycle and be back at about y value of 1 at 8 because the period is 8. So now I have my first anchor point and my last anchor point. The third anchor point is going to be halfway between there, and it's on the axis of the curve as well. Halfway between those first two anchor points, the first and the middle, I'm going to be at my maximum. To get the maximum, I'm now looking at my amplitude of 3. So from that axis of the curve, I need to go up 3 units. So 1, 2, 3. There's my maximum at 2, 4. And then I'm going to graph the fifth anchor point, which is the minimum, and it's halfway between the last two anchor points. So it'll be at 6, and the amplitude is 3, so I want to go down 3 units from that axis of the curve. 1, 2, 3. I'm being mindful of my scale. Every 2 blocks is worth 1 unit. So now I can draw one cycle of this sinusoidal curve, and always do it with a nice freehand, smooth curve. You don't want jaggedy saw teeth. You want them to be a nice smooth curves. So once we've got that, it's really easy now to extend that curve. I know every 2 blocks I'm at one of my anchor points. So I'm going to go up to a max. 2 blocks later, I'm back at the axis of the curve. 2 blocks later, I'll be at my min. 2 blocks later, I'm back at the axis of the curve. So now I've sketched that for my domain of 0 to 16 for my x. So you want nice smooth values here. And you could continue that on. I'm just going to draw some arrows here to say that it does actually continue, but we need a minimum of 0 up to 16 there. Okay, so stepwise, sketch in your axis of the curve. Plot your first, last, and middle anchor points on that axis of the curve using the length of the period to get there, and then use your amplitude to get where your max and min will go. I'm going to type those steps up here, and you might want to copy those down in your notes as well. So it'll take some practice to get this figured out and to get good at it, but with practice you should be able to get good at it.